The piercing darkness is punctured by an eerie neon glow that slowly begins to brighten. The source of the strange illumination soon becomes clear. A glow-in-the-dark, jellyfish-like creature is propelling itself upwards from the murky depths in a silent ballet. But this is not an earthly scene. These are not the fathomless waters of the Pacific or the Atlantic. In fact, this ocean contains more water than all of Earth's oceans put together. An uncrewed submarine is charting the sea beneath the frozen ice sheets of Jupiter's moon Europa. It has just found the first evidence that life does indeed exist beyond the Earth. A discovery like this is the ultimate dream of many an astronomer. Yet so much is made of the search for a second Earth that we often forget that there are other possibilities. Where else in this vast and amazing universe could life find a home? And just how weird and wonderful could it look? If you enjoy diving into the wonders of space, don't forget to subscribe for much more to come. Water worlds like Europa are a stark reminder that we must be careful not to pigeonhole potential for life elsewhere in the universe. Just because our planet is the only one we know of that has life, that doesn't mean that it's the only type of place that can. For one thing, smallish rocky planets like the Earth are not the most common type of planet in the universe. The more astronomers learn about exoplanets, planets that orbit stars other than our Sun, the more they are astonished by what they find. In our solar system, the planets are neatly divided into two groups. There are the small, rocky planets close to the Sun, outflanked and outgunned by the four giant planets lurking further out. Size-wise, there is nothing in between. Yet astronomers are discovering that planets in that very size gap are the most abundant kind of planet in the universe. These betwixt and between worlds are known as super-Earths. They can be twice the width of the Earth and up to 10 times as massive. Anything living on the surface of a planet to the top end of both of these scales will experience a gravitational pull 2.5 times stronger than on Earth. Tall, rangy life forms like the gangly giraffe or the towering giant redwood tree will become an impossibility. Any life would have to exist much closer to the surface. Perhaps the planets with the strongest gravity are home to snake-like creatures whose only option is to relentlessly heave their heavy bodies along the ground. It isn't just a life that would be shorter on super-Earths, mountains would be too. This would lead to a much flatter terrain, one that perhaps would only just poke out of the oceans here and there. A world of sprawling archipelagos and peninsulas instead of the jagged shards of Himalayas, Andes, and Alps. Biologists suspect that this could be a real boon for biodiversity, with a rich array of marine and aquatic life potentially frolicking in the ubiquitous shallows. If super-Earths remind us that Earth isn't the most common kind of planet, the Sun isn't the most common type of star either. Only around 7.5% of all stars are Sun-like. A full 75% are much smaller, red dwarf stars, making them the most abundant in the universe. Life around red dwarfs would have a vast array of challenges to overcome, however. For one thing, staying warm enough for water to be liquid means orbiting much closer to the star. Being at the right temperature usually also means you have to orbit inside the star's tidal lock radius. This is a distance within which the planet's rotation becomes synced, with one side always facing towards a star and the other side perpetually pointing away. This setup echoes our own moon, which is tidally locked to the Earth. One side of the planet would be scorching hot, the other frigidly cold. That is, unless a thick atmosphere allowed strong winds to howl around the planet and redistribute some of the heat. Perhaps some red dwarf planets are home to giant land whales, cavernous creatures that yawn at a breeze in the hope of snaring a meal, much like Earth's whale filter krill from seawater. Have you ever looked up at the night sky and wondered about the many mysteries of the universe? With Imprint, the sponsor of today's video, you can turn curiosity into real knowledge quickly, conveniently, and visually. Maybe you've already slipped on that first resolution you made. Don't worry. Here's your chance to start a habit that's not just achievable but truly rewarding. Learning with Imprint is a simple and effective way to make progress every day, whether it's 2 minutes in the morning or a 10-minute session before bed. One of the lessons I'm diving into right now is all about star formation and black holes. I am looking forward to getting into the full course on the science of happiness next. Imprint breaks down complex concepts into bite-sized lessons that are super easy to follow. Most of these lessons only take a few minutes to complete. So even if you're busy, you can squeeze in a little learning every day. Imprint is designed for modern learners who want to understand the core principles in essential topics. Their interactive animations don't just look amazing. They actually help you understand and retain the material, making learning feel effortless and engaging. Instead of mindlessly doom-scrolling, imagine mastering essential topics in psychology or philosophy, history or finance, leadership or business, health or science, plus so much more. Imprint makes it all possible. So join millions of learners like me and start your journey into fascinating topics today. Click the link in the description to try Imprint for free for 7 days and get 20% off an annual membership. Another factor to contend with is that there will be less light around when orbiting a dimmer star. Much of the light spat out by red dwarfs is, unsurprisingly, in the red part of the spectrum, even spilling over into the infrared. On Earth, plants need all the colors hidden in sunlight. Blue light is especially important for healthy growth. This hue would be sorely lacking on a red dwarf planet, so any plants there would have needed to evolve differently. Some astrobiologists have suggested that their leaves would be black in order to absorb as much energy as possible from the little that's available. Plants use their star's energy to photosynthesize, the chemical process of turning light into sugar. But plants aren't the only ones who employ the same trick. On Earth, there are also species of photosynthetic bacteria. Purple bacteria, for example, contain a pigment that makes them good at absorbing infrared light. Planets around red dwarfs could well be eerie places, with low light levels hiding forests of jet-black plants, surging from a ground carpeted in mats of purple bacteria. If life around red dwarfs is life on the edge, it pales in comparison to the conditions life would have to endure on a planet orbiting 2 stars. Around half of the stars in the universe exist in multiple star systems, calling to mind Luke Skywalker gazing longingly at the twin sunsets on his home planet of Tatooine. The orbits of such circumbinary planets are usually distinctly elongated, resembling an oval as opposed to the almost perfectly circular orbit that Earth enjoys around the Sun. After all, these unusual worlds are caught in a tug-of-war between the gravity of 2 stars. In the parlance of astronomers, these orbits are highly eccentric, which sees a planet plunging close to the twin stars before being flung considerably further out. This would lead to dramatic swings in temperature over the course of a single orbit. Any life here may well have to employ some form of hibernation or another method for dealing with the extreme cold. Perhaps it could resemble the red flat-bark beetles of Alaska, who produce a protein that acts as an antifreeze, allowing them to endure sub-zero temperatures. If Earth is anything to go by, then life is tenacious. This is an important lesson to remember as we go searching for life elsewhere in space. A reminder to keep an open mind. If life can find a way to survive, and even thrive, then it almost certainly will.